What's up guys, this is Masi. Welcome to another video. In this video I want to give you some examples regarding instantaneous velocity and speed. The first question, it says an electron moving along a x-axis has a position given by x equals to 16t times e to the power of negative t meters, where t is in seconds. How far is the electron from the origin when it momentarily stops? When it says stops, it means that the velocity is zero. Velocity is zero. So we need to find out at what time velocity will be zero. So as you know, velocity is dx over dt, which is the first derivative of x. So we need to find out the derivative of 16t e to the power of negative t divided by dt. So I'm going to take 16 out. And after that we have product rule is going to be dt over dt times e to the power of negative t plus t times de to the power of negative t divided by dt. So therefore it's going to be 16. dt over dt is 1 times e to the power of negative t. And here we have t times the derivative of this one is going to be negative 1 e to the power of negative t over dt. Again, these two cancel out, so it will be 16 e to the power of negative t minus t e to the power of negative t. Or we can say 16 times 1 minus t times e to the power of negative t. So this is the velocity. At what time this velocity is going to be 0? So obviously 1 minus t is going to be 0. So it means that t equals to 1, or it means that t equals to 1 second. So it means that after 1 second it's going to completely stop. Then it says how far is the electron from the origin when it momentarily stops. It means that we need to sub t equals to 1 into the equation. So it's going to be x equals to 16 times 1 times e to the power of negative 1. So 16 times e to the power of negative 1. That's going to be 5.88 or approximately 5.9 meters. That's the final answer. In this example, we have if a particle's position is given by x equals to 4 minus 12t plus 3t squared, where t is in seconds and x in meters, what is its velocity at time equals to 1 second? So here the motion is given, the position is given, so we know velocity is going to be the first derivative of x with respect to t. So we need to find out the derivative of this guy. 4 is going to be 0, negative 12t is going to be negative 12, and 3t squared is going to be 6t. That's the first derivative. And it says that time equals to 1, so we substitute 1 in here. It's going to be negative 12 plus 6, which is going to be negative 6 meters per second. Part B, it says, is it moving in the negative or positive direction of x just then? So we can say that since velocity is negative, it is moving in the negative side of x direction at time equals to 1 second. So it's going to be in the negative x direction. Part C says, what is its speed just then? Speed, the side is not important, so it's going to be the absolute value of velocity. Since it was negative 6, has to be plus 6 meters per second. So that's the speed. Part D, it says, is the speed increasing or decreasing just then? We can say that since the speed is going to be the absolute function of negative 12 plus 6t. We can say from 0 to 2 seconds, speed was decreasing, and at time equals to 2 it becomes 0. Why? Because when you sub 2 here, it's going to make it 0, and then from 2 to 3 it is increasing, and then it keeps going up. Part E, it says, is there ever an instant when the velocity is 0? Yes, because when we had it negative and it becomes positive, it means that we have a moment that the velocity is going to be 0. How do you find it? It's going to be negative 12 plus 6t equals to 0. It means that at time equals to 2 seconds, velocity is going to be 0. F. It says, is there a time after t equals to 3 seconds when the particle is moving in the negative direction of x? It means that if velocity is negative. So we know velocity is going to be negative 12 plus 6t. So we are talking about time greater than 2 or greater than 3 and above. On all this, velocity is 0 and it's not going to be a negative. So the answer is no. In this example, we have the position function x as a function of time of a particle moving along an x-axis is x equals to 4 minus 6t squared, with x is in terms of meters and t in terms of seconds. Part A, it says at what time, and B, where does the particle momentarily stops. Part C is saying that at what negative time, and D at positive time it passed through the origin. So we have x as a function of time is 4 minus 6t squared. When we want to find out the velocity, we need to find out the first derivative. The first derivative of 4 is going to be 0. The first derivative of negative 6t squared is going to be negative 12t. And then we need to make it equal to 0 because it says momentarily stops. It's going to be at time equals to 0. It's going to momentarily stop. And in order to find out the location, which we need to answer the part B, where does that happen? T equals to 0, we sub it there. It's going to be 4 minus 6 times 0. It's going to be just 4. C, at what negative time and what positive time pass through the origin? So it means that x equals to 0 when it's saying that it's going through the origin. So it means that 4 minus 6t squared equals to 0. It means that 6t squared equals to 4, or t squared equals to 4 over 6 or 2 over 3. So t will be plus minus square root of 2 over 3. That's going to be plus minus 0.82 seconds. So this is the answer to part C and D. In this question, we have the position of a particle moving along the x-axis. It's given by centimeters, in centimeters by x equals to 9.75 plus 1.5 t to the power of 3, where t is in seconds. Calculate A, the average velocity during the time interval t equals to 2 to t equals to 3. So basically we remember the average velocity is delta x divided by delta t. We need to find out the delta x, which is going to be x2 minus x1 divided by t2 minus t1. So x at t equals to 2, let's calculate it here, is going to be 9.75 plus 1.5 times 2 to the power of 3. And x at t equals to 3 is going to be 9.75 plus 1.5, 3 to the power of 3. So that will be, it's going to be 21.75 centimeter. That's going to be 50.25 centimeter. So when you sub it there, it's going to be 50.25 minus 21.75 divided by 3 minus 2. That's going to make it 28.5 centimeter per second. Next one, it says find out the instantaneous velocity at t equals to 2 seconds. So when it says instantaneous velocity, it means that we need to find out the first derivative of x with respect to t. So it's going to be 9.75 is going to be 0. The first derivative of this guy is going to be 3 times 1.5, which is going to be 4.5, and t cubed is going to be t squared. So at t equals to 2, velocity will be 4.5 times 2 squared. So that's the 18 centimeter per second. That's the instantaneous velocity at time equals to 2. At time equals to 3, we need to do the same thing. Velocity will be 4.5 times 3 to the power of 2. So that will be 40.5 centimeter per second. Next one is gonna be t equals to 2.5 seconds. Just sub it there again. 4.5 times 2.5 to the power of 2. That will be 28.1 centimeter per second. Part E, it says the instantaneous velocity when the particle is in midway between its position at time equals to 2 and times equals to 3. So we have two different positions. We had it earlier. It's gonna be $21.75 plus 50.25, which we got it in part A, divided by 2 because it says halfway. That's gonna make it 36 centimeter per second. Actually, that's x. It's gonna be just centimeter. It says that what's the instantaneous velocity? So 36 equals to 9.75 plus 1.5 t to the power of 3. We need to find out the value of t in here. So I'm gonna solve it. 36 minus 9. That's gonna make it t cubed is gonna be 17.5. So t will be cube root of 17.5. It's gonna be 2.6 pretty much second. And if you want to find out the instantaneous velocity, we need to sub it in this formula. 4.5, 2.6 to the power of 2. That will be 2.6 to the power of 2 times 4.5 is going to be 30.4 centimeter per second. That's the answer to the part E. I hope you enjoyed this video. Please leave me a comment if you have any question, and I get back to you as soon as possible. Thank you for watching and have a great day.